Dear students, let us begin the second part of the lesson, in which you will be learning about the random sampling distribution from normal parent population. Random sampling. In the statistics, random sampling refers to the process of selecting individuals or elements from a population in such a way that each member of the population has an equal chance of being included in the sample. If you look at the picture, there are 12 individuals. They are called populations. From these 12 individuals, we can collect the samples in a random manner. How we can select the random manner? That is, we have to give equal chance of probability for each and every individuals. What is the chance for selecting the first one? 1 by 12. What is the chance for selecting the second one? 1 by 12. Similarly, what is the chance for 12th person is 1 by 12. Therefore, likewise, we are giving equal chance of probability for all the individuals. It is called random sampling. Random sampling helps to ensure that the sample is representative of the population, allowing for generalizations and inferences to be made about the population based on the sample data. The random sampling distribution refers to the distribution of sample statistic. For example, sample mean, sample proportion, that would be obtained from multiple random samples of the sample size drawn from the sample population. In the case of the sample mean, the random sampling distribution represents the distribution of the sample means obtained from the distribution. When the parent population follows a normal distribution, the sampling distribution of the sample mean will also follow a normal distribution regardless of the sample size. This holds true even if the population itself is not normally distributed. The central limit theorem states that as the sample size increases, the sampling distribution of the sample mean approaches a normal distribution regardless of the shape of the population distribution. A normal parent population is a population in which the values or observations follow a normal distribution. The normal distribution, also known as a Gaussian distribution, or it is a bell-shaped curve. It is characterized by its symmetric shape, with the mean, median and mode all being equal and located at the center. In a normal distribution, the values are evenly distributed around the mean following a specific pattern. If you look at this figure, there is a parent population. We can select the sample from that parent population. They are called samples. The properties of the random sampling distribution from a normal parent population include mean, standard deviation. The mean of the sampling distribution of the sampling mean is equal to the mean of the parent population. The standard deviation of the sampling distribution, also known as the standard error, is equal to the standard deviation of the parent population divided by the square root of the sample size. Safe. The sampling distribution is approximately normally distributed, especially for large sample sizes, even if the parent population is not normally distributed. We can define sampling distribution of the sample mean. When multiple random samples of the sample size n are taken from a normal population, the distribution of sample means will be approximately normal, regardless of the shape of the parent population. This is known as the sampling distribution of the sample mean. Sample size. The sample size small n plays a crucial role in determining the shape and precision of the sampling distribution. As the sample size increases, the sampling distribution becomes more tightly concentrated around the population mean, resulting in a smaller standard error and a more precise estimate of the population mean. Law of large numbers. The sampling distribution approaches the population mean as the sample size increases. In other words, we can define the larger sample size, the closer the sample mean to the population mean. Central limit theorem. The central limit theorem is a fundamental statistical concept which states that regardless of the shape of the parent population, the sampling distribution of the sample mean tends to follow an approximately normal distribution as the sample size increases. This theorem is particularly powerful because it allows us to make inferences about the population parameters based on the properties of the sampling distribution. Standard error of the mean. The standard deviation of the sampling distribution, also known as the standard error of the mean, it is rendered as a SE, is determined by the population standard deviation sigma and sample size n. The formula for the standard error of the mean is sigma by square root of n. It represents the average amount of variability or dispersion expected in the sample means. Understanding the random sampling distribution from a normal parent population is very essential for making valid statistical inferences. It enables us to assess the reliability and precision of sample statistics, make comparisons, perform hypothesis tests, and construct confidence intervals to conclude population parameters. If you look at this figure, we are having sample population distribution as well as parent population distribution. These diagrams are represented sample population distribution. This curve represent parent population distribution. Dear students, let us summarize what we have learnt in the second part of this lesson. We have discussed elaborately random sampling distribution and normal parent populations with suitable examples. Dear students, I hope you understood all the concepts. We will continue in the next video. Thank you.